Okay, so now we look at averages. All right, so when it comes to averages, we will be typically be when we go through the what do you say, the different concepts and formulae, we'll see that there's a wide variety. It can be arithmetic mean, geometric mean, or harmonic mean. Or within arithmetic mean, you can have simple average, then you have weighted average, then you have an assume mean concept, or an assume mean with weighted average and all of that. But when it comes from an exam perspective, CAT questions and all, it's been heavily skewed towards a very simple elementary concept, which is average equals total divided by number of terms. That's it. That's the simple concept around which most of the questions are. We look at them. But what they're expecting over here is, or if it's not going to be straightforward, right? They're not just going to give you the total and the number of terms and ask you to find the average. It's not school anymore. So they're going to be some twists and turns. They're going to be word problems. You've got to visualize. You've got to think about the scenario, and then come back to the structure. But I don't want to use this structure. The structure we'll end up using is average into number of terms equals total, right? Or I might write number of terms into average equals total, either which ways, right? So average into number of terms is total. That's the base formula with which we're going to be operating for most questions here, right? So a lot of questions under averages, they're going to give us the average and or the number of terms, but they won't speak about total. They won't be mentioning total anywhere in the question. We are required to use this to find the total and work with it and come back to this, to whatever they are asking us to find. We'll look at those questions, right? So before we start, arithmetic mean, plain simple concept, right? So as I just said, arithmetic mean is also called average or simple average as we call it. And it simply means add up everything. If you want a formula per se, or writing it down this way, x1 to xn divided by number of terms, or some might say sigma n equals 1 to, or I equals 1 to n xi divided by number of terms. Those who want to remember it this way, but forget all of these. Forget all of these. I mean, it's all correct only. I'm not saying no. Just stick to the plain old simple. Total by number of terms is average. That's it. Right. So that's it. To understand in simple terms or simple words, that's the more important part over here. Right. So now, average of numbers in AP, right? Arithmetic progression. I'll be covering that in detail in the progressions lesson, right? But nevertheless, arithmetic progression, we all know what it is, right? So if it's going to be 2, 5, 8, and 11, and so on, right? Let's say there are only 4 terms over here. What is the average over here? The average, if you want to add up everything and divide by 4, we're going to get 2 plus 5, 7, plus 8, 15, plus 11, which comes to 26 by 4, 13 by 2, 6.5. Or I can just say first term plus last term by 2, 2 plus 11 by 2, right? By 2 over here because I'm taking only 2 terms. And that comes to 6.5 as well. I think most of you at the stage will be knowing it. Arithmetic progression average is first term plus last term by 2, right? So around this, a question that turned up. Okay, so on to question 1. The arithmetic mean of scores of 25 students in an examination is 50, right? So this is how they typically give us. N is provided, average is provided, the total we might have to work with to get the whatever we need to find. 5 of these students stop the examination with the same score, x, 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 5 of them 5x. If the scores of the other students are distinct integers with lowest being 30, the maximum possible score of the toppers. So sum of all the scores is a constant because n into average over here, which is 25 into 50, gives me the total score over here of all the students, which is 1250. 1250 I have over here. Now, 5 of them are toppers. The 5 toppers over here, 5 into x, I have to maximize them. So the remaining fellows should be as small as possible because the total is 1250. So what is the smallest values I can give for the remaining 20 people? The remaining 20 people, what do I know? They are all distinct integers with the lowest being 30. I have to put their scores as low as possible. The lowest I can give them are 30, 31, 32. They all have to be distinct also, and goes on till what? I need 20 scores. From the 25, 5 are toppers, equal scores, same score they had. The rest were distinct. Starting from 30, I need 20 distinct scores. It's going to end with 49 over here. 30 to 49. How am I getting 49? Not, why not 50? Because 30 to 50 both inclusive is 50 minus 30 plus a 1, right? I have to add 1. We've seen that in the numbers, right? Counting consecutive integers, y minus x plus 1 both inclusive. So if you're wondering where should I stop over here, where should I stop? I don't know this y term. You can just say y minus 30 plus 1. Y minus 30 plus 1 should be 20 terms totally. So I get a minus 29. Move that there. It becomes a 49. My last term over here is 49. These are 20 terms over here, right? So once you identified this to be 20 terms, what is going to be the sum total of these values, right? Can't be manually adding these. They are all in AP. Common difference is 1. Again, in arithmetic progression, the sum total of these 20 terms is n into average. What is n over here? 20 terms. What's the average for AP? First term plus last term by 2. 30 plus 49 by 2. Right? I shouldn't be doing all of these. I should just say 30 plus 49, 79 into 10, 790. So 790 is the lowest possible scores I can give for the 20 students who are not the toppers. So if I remove that, I'm getting my 5 toppers score. 5 toppers over here is 210 plus 250 comes to 460. If 5 of the toppers are 460, then each topper is going to be how much? 460 by 5 comes to 92, right? What is asked over here? The maximum possible score of the toppers is what? The maximum possible score of the toppers is 92, right? That should be the answer. However, some people challenge this question in the exam, post the examination. They said you've used the word toppers and as plural over here. It's non-MCQ. So if you're saying toppers and maximum possible score of the toppers, it should be all 5 of them put together. The answer should be 460. And CAT decided that both answers will be accepted after this. They said 92 or 460, either of it if you mark, we're going to give full 3 marks. The next, I have a bunch of concepts over here, right? So we'll just quickly go through the concepts, then we'll take up more examples, right? So we'll go through a few concepts very quickly, right? Assume mean and weighted average. Now, weighted average, as we know, I'm not going to get into specifics and explain as to why, but from a formula perspective, x bar equals weight 1 into x1 plus weight 2 into x2, and so on till the weight of n into xn divided by the sum of all the weights, right? And so on till Wn. Now, the key thing for us to note over here is when it comes to weights, it's just weights. So therefore, the absolute value doesn't matter. I can take the ratios. For instance, let us say somebody on has rated 5 products. Let's say there is a product which has 5 different ratings, right? So the ratings are XI, let's call it 1, 2, 3, 4, and 5. And the ratings given are the number of ratings, right? Number of ratings are like 12, 24, 36, 48, and 60. Then what is the average rating over here? To find the average, I first have to find the total value. If 12 people gave 1 rating, total of 12 into 1, 12. 24 people give 2 rating, 24 into 2, 48, and so on, and add them up and divide by the total ratings. But then you need to understand, I'm finding the average for this. So this is nothing but my weights. When it comes to weights, I can always rewrite my weights in the form of a ratio. Ratio is fine. Whatever is common over here, I can cancel. All of them are divisible by 12. I'll divide all of them by 12. I get 1, 2, 3, 4, and 5. For these ratings 1, 2, 3, 4, 5, I can multiply with the respective weights and I get XI, WIS 1, 4, 9, 16, and 25. Can add these up. I'm going to get a 55 over here. So 55 divided by sum total of the weights, which is 15. So the average over here is going to be 55 by 15 divided by 5, you get 11 by 3, which comes to a 3, 2 by 3. Right. So what have we done over here? We have not gone with the weights as it is. These I can divide all of them by the same term. My ratio doesn't change. My average doesn't change. The reason being, weights are there in the numerator and denominator. Whatever is common, a 12 I can take common from each of these in the numerator and in the denominator and cancel it out outside. So therefore, ratio of weights are enough. I don't need to use the absolute value of the weights over here, right? So that's the first one with weighted average. On to assume mean, right? So when we have to find the average of, let's say, 347, 349, 355, and 361, right? If I have to find the average of these, adding all of them up and then dividing by 4 can be done. It's a little cumbersome. What could be better over here is to take an assume mean over here, right? And these are my xi. And my assume mean, I can take it as, let's say, 350. It can be one of them or it can be any number between them, right? So assume mean is 350 everywhere. So therefore, what I'm going to do is I'm going to subtract each of these by the same value. I'm getting a minus 3, minus 1, a 5, and a 11. Now when I add these up, I'm going to get a 12, right? So 12 over here, what is the average of 12? 12 by 4 is coming to 3. Now this is actually lower than the actual average by 350 because I subtracted a 350 everywhere. My average has become lower, so I have to add back a 350 and I'm getting 353 as the answer over here. Once again, quick look. If I'm going to be subtracting and assume mean everywhere, then my average is going to be lower by that much. As my average of 3 was lower by 350, I'm going to add back the 350 to get my actual average of these 4 items, which comes to 353. Another way we can look at averages. What is this 353? What is this 353? We have two elements to the left over here at 347 and 349, and we have a 355 and a 361 here. The distances from all these elements on the right, 2 units and comes to 8 units over here, right? 8 units over here. And here I'm getting 4 units and I'm getting 6 units over here. Sum of these is 10, sum of these is 10. So sum of the distances of the units to the left of the average, 4 plus 6 is 10, and the sum of the distances of the units on the values on the right of to the right of the average, that comes to 10. Both of them are going to be equal, right? So what does this mean? My average is somewhere in the middle, somewhere in the middle, such that it's equidistant from all of these, as in to the left and the right, it's not biased, somewhere in the middle. So that the sum of distance on the left and sum of distance on the right are all equal, right? That's our average. How do we find it? Sum of everything divided by number of terms, or in cases like these, subtract the assumed mean and then work with it, right? So at this point, I think a couple of other things that should strike for all of us, which is if every term is going to be subtracted by the same value, then the average is lower by that value. If every term I'm going to add by the same constant, the average is going to be increased by that constant, right? So if every term is going to be multiplied by the same value, does it mean that the average gets multiplied as well? Yes, right? So we will look at that actually when it comes to geometric mean, right? A quick comparison over there. Right. So let's understand geometric mean prior to that. So arithmetic mean over here was defined as x1 plus x2 and so on till xn divided by number of terms. Sum of everything into 1 by n. Sum of everything, I mean, let's just leave it at that. Sum of everything into 1 by n. Look at it that way, right? Geometric mean is what? Wherever it's a plus, I'm going to use a product over here, right? I'm just going to multiply. So it's going to be x1, x2, and so on till xn. Here, as I multiplied with 1 by n, I'm going to raise it to the power of 1 by n, right? So after addition, repeated addition is multiplication. Repeated multiplication is exponent, right? Whatever was addition over here turns into multiplication, right? And whatever was multiplication here, right? For instance, the sum of terms was multiplied with 1 by n, right? Which is what is happening over here. This entire bit into 1 by n is same as whole divided by n. So whatever was being multiplied with 1 by n, I'm going to raise it to the power of, it's going to become an exponent over here to the power of 1 by n. And that's geometric mean for you, right? The plus symbols are replaced with multiplication. The into becomes an exponent over here. That 1 by n gets to the power, right? So that's geometric mean. Now, what's with arithmetic mean and geometric mean, right? So let's look at it this way, right? So if you take arithmetic mean and geometric mean, if I'm going to add or subtract a constant from each of these terms in my AM, if each of these terms I'm going to add or subtract a constant, my arithmetic mean also the same impact is going to be there. There's going to be a plus the constant or minus the constant. If I'm going to multiply or divide a constant from each of the terms, then my arithmetic mean also, there is going to be an into or a division happening for each of the, for the overall arithmetic mean. What I mean is, if I have the values 2, 5 and 8, the average over here is 5, right? If every term I'm going to multiply with 3, right? I'm multiplying each term with a constant and I'm getting 6, 15 and 24. The average over here is 24 plus 6, 30 plus 15, 45 by 3. Average becomes 15. How? As every term got multiplied with a constant, the average also got multiplied with a constant and becomes 15. So whatever you're doing to each and every term, if it's an addition or subtraction, multiplication or division by a constant, it works. If you're going to raise it to the power of a constant, is the same going to happen over here? No, it doesn't, right? Let's call it not applicable or doesn't happen. How do I denote that? No. And in the case of geometric mean, everything gets pushed down, right? Everything gets pushed down. Addition becomes multiple, so it just moves down. So therefore, if you're going to subtract, if you're going to multiply or divide by a constant, yes, it will happen. If you're going to raise it to a power of a constant, each term, same happens to geometric mean, but addition doesn't happen. Addition or subtraction doesn't help, right? The same pattern doesn't continue. When you add or subtract a constant from every term, your geometric mean doesn't get added or subtracted by the same constant. There is no set pattern over there, right? So to slightly put it in a different way, right? So if you're going to look at impact, right, AM and GM, whether it's going to change by the same constant for plus or minus, yes. For into or like division, yes. For to the power of a constant, no. Geometric mean is a no here, but the other two are yes. When you're raising every term to the power of a constant, geometric mean also gets raised to that, right? So that's geometric mean. Applicability in some questions, we'll be looking at that, right? Now, in terms of, the next is geometric mean and where can I use it? CAGR. I'm not going to get into it in detail because we saw that with the interest and growth revision, right? Compound annual growth rate is what it stands for. It's nothing but the product of all the multiplication factors. 1 plus x1 into 1 plus x2 into 1 plus x3. Let's say these are three rates. We might use the terms R1, R2, and R3 over here, right? And whole to the power of 1 by 3. How many ever terms I'm multiplying? Subtract the 1 multiplication factor. I'm changing into a change factor into 100%. That's my CAGR. Now, some of you might be asking, R3 by 100 I didn't use. If R3 is in the percentage form, then yeah, then you bring in a divided by 100. Be flexible with the use of the formula. Understand how it works and don't just blindly memorize it. Yep, that's CAGR for us. Not going to get into it in detail right now. Let's look at the next one quickly. Harmonic mean, formula and application, right? So we've seen the application of this. We saw this in the time and speed revision, right? Average speed, where distance is a constant. We're going to use harmonic mean where d distances are constant, right? Where you have product of two terms which is a constant, right? S into t is d, and d is held constant, right? Distance for 1/3 of the distance at this speed and 1/3 of another speed. You can just take the harmonic mean of the speeds, and that's the average speed, right? So there we can apply. So in terms of formula, what is that going to be? X bar over here is, okay, let's look at arithmetic mean, right? Arithmetic mean is Once again, x1 plus x2 plus and so on till xn divided by n. Harmonic mean is the reciprocal first. So n goes up. All my x1, x2 are coming here. For each of those, I'm going to apply the reciprocal. 1 by x1 plus 1 by x2 and so on till 1 by xn. That is the formula. That's all you need to know at this stage. Why what? You can leave that part, right? So if you want to understand that, probably you can get to the base of why is the average speed when distances are equal the same, then you'll get a hang of this as well, right? Harmonic mean. Now, very quickly, as I said, I'm just rushing through this because I want to take up examples around questions which are turning up in the exam, right? AM, GM, and HM for two terms, right? For two terms, our arithmetic mean, let's say A and B is A plus B by 2. GM over here is going to be root of AB, AB to the power of half. And HM over here is 2AB by A plus B, right? So if you do 2 by 1 by A plus 1 by B, you take the LCM, move the AB up, this is what you get. You write it as AB whole power half, and this is what you get. A plus B by 2, that's what it is always. What's the inequality around this? Arithmetic mean is always greater than equal to the geometric mean, is always greater than equal to the harmonic mean when you have a set of positive terms given, right? Always your arithmetic mean is greater than equal to geometric mean, which in turn is greater than equal to the harmonic mean. Why the equal to symbol? Is one scenario where all three of them are going to be equal when all my x elements, all my terms are going to be equal. For 5, 5, and 5, my AM is 5, arithmetic mean is 5, geometric mean is also 5, harmonic mean is also 5. If one of them is going to be different, or just one of them, slightly different, 4.99 also, that's fine, 4.9, then this inequality applies. AM is going to be, this time around, greater than GM, is going to be greater than HM because one of the terms is different, right? So that's it when it comes to this particular concept. Now on to what I've been saying that we're going to get into in detail, past averages questions. And a lot of these averages questions, in the recent past, I've been seeing with minimum and maximum being asked. We just took up one example just now, right? So let's take up this example, all of you. Not all of these questions are going to be having minimum and maximum, but let's just do it, right? Remember that min and max is also going to be the focus. CAT has been having a lot of questions around this in the recent past. So let's look at question 2. In a football tournament, a player has played a certain number of matches and 10 more matches are to be played. Okay. 10 more are to be played in the future. So some number of n number of matches have happened. If he scores a total of 1 goal over the next 10 matches, okay, 1 over the next 10 matches, his overall average will be 0.15 goals per match. That's the final average given, right? So they're not saying average is going to increase, they're saying this is going to be your final average. So how many goals scored so far? We don't know that. Therefore, we should take let G be the goals scored so far. I mean, don't need to be writing all of this, should be in the mind. So if G goals have been scored so far and N matches have been played, if 10 more matches are going to be played and one more goal is going to be scored, the overall average is becoming 0.15. Now, on the other hand, if he scores a total of 2 goals over the next 10 matches, right? N plus 10 again, but G becomes G plus 2. Then what's going to happen is going to become 0.20 goals per match. That's becoming the average over here. The number of matches he has played, right, is what? I need to find the number of matches played. I can, in fact, look to get rid of the number of matches to begin with because left-hand side's over here. N plus 10 is common. 2 equations, 2 variables. I can just divide. And what am I getting? G plus 1 by G plus 2 because N plus 10 is cancelled. G plus 1 by G plus 2 equals 0.15 by 0.20, 15 by 20, which is 3 by 4. And I get 4G plus 4 equals 3G plus 6. And I get G equals 2. G equals 2 is done. Plug it back over here. G equals 2. 2 plus 1 is going to be 3 divided by N plus 10 equals 0.15. 0.15 is 15 by 100, which is 3 by 20. Cancels. 20 equals n plus 10, n equals 10. And we get the answer 10 over here. The other approach over here, right? So although it looks like dividing is what is going to help us the most, as the denominators are the same, I can subtract as well, and I can get rid of the g. The bottom minus top, g plus 2 minus of g plus 1 is going to give me 1 divided by n plus 10, right? 1 divided by n plus 10. 0.2 minus 0.15, that gives me 0.05. And 0.05 is nothing but 1 by 20. Cross multiply, you get 20 equals n plus 10. N equals 10, right? This becomes a lot quicker. Now, can you land up with this bit even without touching all of this, right? That's the key. If you conceptually look at it and nothing else, right? So you realize that with certain number of terms, increase in total divided by number of terms should give me the increase in average. If you conceptually look at it, increase in total, what happens? First scenario, you have one goal scored, it's 0.15 goals per match. Second scenario, you have 2 goals scored. Then compared to the first scenario, it's one extra. One extra goal, right, divided by n plus 10 should give me increase in the average. 0.15 has become 0.2, which is 0.05. You could bypass all of these and land up with this if you're 100% conceptually clear. I'm not expecting this completely in the exam, it's fine. But these are things you can note and you could apply it in different parts, right? So 20 equals n plus 10 and get n equals 10. Just one variable, one equation. Goals you don't need to touch at all. What's the concept again? If an increase in total is triggering an increase in average, increase in total divided by number of terms is the increase in average. That's it. In a group of 10 students, the mean of the lowest 9 scores is 42. Okay. The mean of the highest 9 scores is 47. For the entire group of 10 students, the maximum possible mean exceeds the minimum possible mean by what? Okay. Mean of the lowest 9 scores. Let x1 be the lowest scorer, x1 plus x2 and so on till it's going to end with x9, right? X9. And what is the sum of all of these scores going to be? It's going to be 42 into 9, average into the number. Okay, so what about the highest 9? Highest 9, I'm going to leave out the lowest fellow x1. I'm going to go for the highest over here. And that's going to be the rest of them ending with x10. And that total is coming to 47 into 9. Okay. Now, what do I need to find over here? The maximum possible mean, sum of everybody divided by 10, right? What is the maximum possible, minimum possible? I have to find the difference of that. Fine. Now, why are they giving me this? What can I do with these two equations over here? 9 variables, 10, another 9 variables, total of 10. I can't solve for them. But what's common over here? x2, x3, x4, and so on till x9 are common. Bottom minus top is going to give me x10 minus x1. x10 minus x1. And x10 minus x1 over here is going to be 47 into 9 minus 42 into 9, which is 5 into 9, 45. x10 minus x1 is 45. x10 equals x1 plus 45. If I move it to that side. Now comes the thing. What are the smallest or largest values my x1 or x10 can take? Right? x1 or x10 can take. Simply put, my x1 over here cannot be lower than the average. This is the smallest fellow over here in this whole thing. Can't be lower than this average of 42. The least value, I mean, the highest value I can give for x1 over here is going to be 42. In fact, can't be exceeding it 42, right? So the average of 9 terms with x1 being the lowest is 42. The max I can put for x1 is going to be 42 itself. 42 itself, where everybody is going to be 42, right? In which case I'm getting x10's value as 87. This is the highest I can give x1. Highest I can give x1. To find the lowest for x1, I can't take that route. Let me think about the other person given over here, x10. Now, what about x10? What is the minimum I can give x10 over here? Where 47 is the average, 47 is the midpoint of all of these people. The minimum value x10 can take, the highest amongst them can take, is 47 itself, where all of them are equal to 47. x10 can be 47 itself, in which case 47 minus 45, 2 becomes the value of x1. The highest possible value of x1 is 42. The lowest possible value of x1 as a result of x10's value, lowest possible value for x10 I can find, highest possible value I can find over here. So therefore this lowers it over here as well, and I'm getting 2. That's it. 42 and 2 are the lowest possible values. Anywhere I can just fit these values in, either into the first or the second. Let's say I'm taking this particular one. What is 47 into 9 coming to? 49s are 360, 7 nines are 63. It is coming to 423. To this 423, who's missing here? X1 is missing. What are the possible values of X1? X1 can be 2 or 42, the range 2 or 42. 423 plus 2 is coming to 425, or 423 plus 42 is coming to 465. These are the two different possible totals I can have, and the two extremes. Divide by number of terms, divide by number of terms is giving me 42.5 and 46.5, the highest possible average and the least possible average. X2 to X10 is fixed. The missing fellow X1, I have to find the highest possible value and lowest possible value, and these are the values. Plug it in over here. 42.5 and 46.5 are the two, the highest and the lowest possible averages. The difference between them is 4. 46.5 minus 42.5 equals 4. That's the answer for this question. The same can be done with 42 into 9 as well. There we need to add the x10 value of 87 or 47. Try that on your own, and you'll once again be getting 42.5 and 46.5. Let's look at question 4. A cat aspirant appears for a certain number of tests. His average score increases by 1 if the first 10 tests are not considered, and decreases by 1 if the last 10 tests are not considered over here. So if his average scores for the first 10 and the last 10 tests are 20 and 30 over here, right? 20 and 30 respectively, then the total number of tests taken by him is what, right? So let the total marks over here, sum total of all the tests be T, capital T. From this total, if I'm going to be removing only the first 10 tests where the average was 20, then I'm removing a total of 10 into 20, 200, and divided by how many terms? Let's say total of n tests, I'm removing n 10 tests, right? So n minus 10. Then what is happening to the average over here? The average is increasing by 1. Average is increasing by 1, which is T by n plus 1. Now, what if it's going to be T minus 300? If I'm going to be removing the last 10 tests where it was 30, the average, and divide by n minus 10, then what is happening to the average? The average is decreasing by 1 if the last 10 tests were removed. That's it. Now, these two, from these two, what we need to find is the total number of tests taken. N is what we have to find. This was very similar to one of the earlier questions we had done over here. If I subtract values, the denominator is the same, n minus 10. This T by n chunk is the same in both cases. T can get cancelled over here. So therefore, the top minus bottom, right? This is the first equation, this is the second equation. First equation minus the second equation. T minus 200 minus of T minus 300. So minus T plus 300 divided by n minus 10 equals T by n cancelled. 1 minus of minus 1 is plus 2. Now T and T are getting cancelled over here. A minus 200 plus 300 is 100, right? So this comes to 100. And 100, if I divide by 2, I'm getting 50 over here. So 50 equals n minus 10, n equals 60, right? 60 becomes the answer over here. So let's look at this question, yeah? So in an apartment complex, the number of people aged 51 years and above is 30, okay? There are at most 39 people whose ages are below 51 years. Aged 51 and above. To visualize this, just draw some sort of a number line of sorts. 51 and above, right? This region, my number of people is gonna be 30. 51 years and above is 30. Yeah, and there are at most 39 people whose ages are below 51 years, right? So it's going to be max of 39 over here. Fine, 39. Let's list it out. Who are below 51 years. The average age of all the people in the apartment complex is 38 years. 8 years is the grand average of all the people over here. What is the largest possible average age in years of the people whose ages are below 51? Those below 51, I have to maximize their average over here. This average has to be maximized. What should I do now? Sum total of everything over here, grand total, there is an average age at 38, it's given to me. Grand average over here is given to me at 38, right? So therefore, this is more or less fixed for me, right? So if I have to maximize one group, the other group's average has to be minimized. The other group average, the minimum possible age for each of these 30 is exactly 51, right? Each of these people are 51 or above, I have to bring them to 51. Another thing to be noted over here is there are at most 39 people. Maximum over here is 39. So n is less than equal to 39. You don't have exactly 39, you have maximum of 39. So first step first, what I would want to do is I would want to find the total age over here. Total age over here for this group who are more than 51 or more, right? The smallest possible total I can give them over there is going to be 30 into 51. That comes to 30 into 50,500 and 1,530. 1,530 is the smallest possible total I can give to these 30 people over here, so that the other side I can increase it. I can put the highest possible value over here. So let me take n as it is, right? So n as it is over here, it has to be less than equal to 39. We can plug that in towards the end, right? And let's observe whatever we can, right? So what is going to be the total value? Grand total is, if I don't know this n, forget this n. So here the number, I'll call it, is 30. This is the n I don't know. This is the average I don't know, right? So I need to have the highest possible average over here. I know that A has to be the highest possible. So NA, right? The total over here, N into A, plus the total over here, 1,530, equals total number of people, N plus 30 into 38, which is the grand average. So N plus 30 into 38 over here. Now we've got to multiply, right, and see as to what we're getting. NA plus 1530 equals 38n plus 30 into 38, 3 into 38, that's a 90 plus 8 3 is a 24, that's going to be 1140. So 1140, if I bring to this side, 530 minus 140, 430 minus 40 is coming to a 390. So I'm getting a 390. NA plus 390 is coming to 38n. So now we need to again now think in terms of A. I want to maximize A. What should be the impact on N and all of that? So let me move N to that side, right? NA to that side. 38N minus NA. 38N minus NA, right? And I have to take an N common, and I get 38 minus A equals 390, right? And where does this go from here? 38 minus A equals 390 by N. 390 by N over here. If I have to maximize, if I have to maximize the average, I have to get the smallest possible value over here. The smallest possible value. If A gets maximized, 38 minus A, the entire term gets minimized. If the entire term is to be minimized, my right hand side should be minimized. My denominator should go up, right? Should be maximized. I wouldn't say this is the most elegant way of presenting the solution, but given this and we need to factor the at most 39, we have to go down this route. If n, what is the highest I can put for n? That's 39. If n is going to be 39, then 38 minus a becomes 390 by 39, which is 10. A over here becomes 28, and that's supposed to be the exactly precise way of solving it. But a lot of people at this stage would have missed the at most, would have just gone with the 39 number directly, which is also fine. They've given over there to cap it 39 into a, when you substitute directly, and you're going to get 28 very quickly as well. You can go ahead with that also. This question is from CAT 2022 slot 2, right? So what do we have here? Five students, including Amit, appear for an examination in which possible marks are integers between 0 and 50. Great. The average marks for all the students is 38. Five of them, average is 38. Total immediately I can say is 38 into 5, which is 190. Exactly three students got more than 32. Okay, 1, 2, 3, 4, 5. Three of them got more than 32. The rest are going to be less than equal to 32. Smallest, highest. Okay, fine. No two students got the same marks. Okay, and Amit got the least marks among the five students, right? So this is Amit, lowest to highest, ascending order. Then the difference between the highest and lowest possible marks of Amit. So I need to find the difference between the highest and lowest of this fellow Amit over here. And 5 over here given to me. Total is going to come to 190. So what can be the thought process over here, right? So how do we work with this 190 figure? Now we need to understand that 0 to 50, I mean greater than 32 over here. Now let's first start with putting in the highest possible mark for Amit. Okay, so let's start with, I'll just start with highest over here. If Amit is the highest, the rest are going to be the lowest possible. The lowest possible, 3 marks. Would I want to give 32, 33, 34, or 33, 34, 35? No, average itself is 38. I need to hit 190, right? If I'm going to go for the highest over here, what is the highest I can give for Amit? All are distinct marks. 32 over here, right? This highest over here is what is going to give me 31 over here, right? It can't be more than 31 because Amit and the fellow next nearby are 32 or below. So highest I can give Amit is 31. It can't be 32. Then this should be 33. Not possible, right? So highest is 31. Just quickly see if it's fine. Adds up to 63. If I remove 63 from 190, I'm left with 127. 127, I can give it as 41, 42, and 44 or something like that. It's fine. This seems okay. This is the highest. Now on to the lowest possible marks for Amit, right? So if I have to reduce it as much as possible, for the remaining 4 people, I have to give the highest possible scores. What's the highest I can give here? 50. The highest I can give is 49. Highest I can give is 48. Adds up to 3 into 49, 147. 147 I remove from 190. I'm going to be left with 43. 43. And if I give the highest of 32 from 43, I'm left with 11 over here, right? So 31 is the highest, 11 is the lowest. 31 minus 11, 20 should be the answer over here, right? So 20. This is from the paper I'd given, 2022 slot 2. On to question 7. Consider 6 distinct natural numbers. Okay, I want 6 distinct natural numbers. And such that the average of the two smallest is 14. Two smallest, average is 14. So the average over here, always I put the smallest at the start. Average is 14. And the average of the two largest over here is 28. Okay. And the maximum possible value of the average of the 6 numbers. If I want to maximize this entire average, I have to put the highest possible values over here. So the highest possible values I can put in the middle terms is going to be influenced by this, right? The highest over here. 5th and 6th are going to be the highest. So I need to put these to be as high as possible. To make these as high as possible, the average over here is 28, right? One to the right and one to the left. Left should be as high as possible. If it is 28, if this is 28, this is also 28, not allowed. They have to be distinct. So just one less than 28. One less than 28, I can have 27 and 29 over here. And as I want distinct numbers, if this is 27, one less than it is the highest possible I can put here. Next highest I can have is 25. Average is 14. I can put whatever I want. I can put 13 here, 15 here. Whichever way, it should add up to 28. Two terms average is 14, total is 28. That's it. So total is 28 over here. Total over here is 51. Total over here is 28 into 56 divided by 6 terms totally. 50, 50 and 20 is 120. 120 plus 15 is 135 by 6. And I can divide this by 3 over here and I would get a 45 by 2, which is a 22.5. Next up, we have some age-based questions, right? So age-based questions, when they turn up with respect to averages, right? So we need to understand what's going to be the impact with averages where ages are given. So total equals average into number of terms. So every year, if every one of those n people are going to grow older by 1 year, my average will also go up by 1. If my average goes up by 1, my total over here goes up by n years. So if there are 10 people whose average age equals 32 in 2023, then these 10 people, their average is going to be equal to 33 in 2024. But their total, right, the average went up by 1, but their total, which was 32 into 10, which is 320, is going to become 330. The average will go up by 10, which is n number of people, so n years, right? So that's it. Simple concept over here, simple concept. Let's look at this question over here, CAT 2007. On to question 8. 10 years ago, the ages of the members of a joint family of 8 people, right? So I have 8 people over here, added up to 231 years. The total is given to me already. Fine. This was 10 years ago. 3 years later, one member died at the age of 60 years. 60 is knocked off from the total, and a child was born during the same year, immediately born. So 60 was removed and 0 was created. Fine. Its a net effect is minus 60. After another 3 years, one member died again at 60 and a child was born during the same year. Net impact is just a minus 60. That's it, right? So the number of people remains 8 because when the person dies, the child is immediately born, right? So it's taken care of. 2 times 60 is removed, right? 10 years ago, the total was 231. If none of these happened, 8 remained 8 as it did, right? The total should have just gone up by 8 into 10 years, which is 80. However, 60 was removed twice. So minus a 120. I don't need to start adding these up, people up till 60 and then a child over here and all of that, because the 60 was just replaced with a 0. That's it. So a minus 120. That's going to be giving me the total age right now. 231 minus a 40, which comes to 191. For this total of 191, I need to be finding the average over divided by 8. 192 by 8 is 24, so this is 23.7 by 8. So 23.7 by 8, the closest over here is option 5, 24 years. This from the year which I wrote in or into I am Lucknow. Yeah. So this is the way we go about with this question. Now, next one is a concept which has not come up in a while. Say anytime it can come. Let's see when it comes up. Consecutive integers, logic and approach. I'm not going to get into, I mean, if this part is not going to be too clear, I want you to refer to the videos, right? Understand it. Consecutive integers, the logic is this. You have n consecutive integers. If one of them is removed, your average is going to be plus or minus. Maximum possible change in the average is going to be plus or minus 0.5. That's it. The average of n consecutive integers always a 0.5 multiple, right? We're going to be using these to solve this question. Now, this is a question which is there, I think, in the lesson as well, right? This is something we should have worked with. Let me just go ahead and solve this, right? So how do we do this? A set of consecutive positive integers beginning with 1 is written on the blackboard. A student came along and erased one number. The average of the remaining numbers is 35, 7 by 17. This 17 over here gives us a lot of, idea about what's going to happen. We'll see how, right? So 35, 7 by 17 is the new average. The new average over here is 35, 7 by 17. The old average could have been the nearest possible zero point 0.5 multiples, which are 35 and 35.5. 35 7 by 17 lies between these two. So the nearest possible zero point 0.5 multiples are these two. These could have been the old average. So what's the old number of terms? The number of terms for n consecutive, the first n consecutive positive integers is 1 plus n by 2. Right? If 1 plus n by 2 is 35, then n over here is going to be 70 minus 1, 69. It's going to be 69 in this case. And in this case, it's a little more. So it has to be 70. 1 plus 70 by 2 comes to 35.5. So old number of terms, we found that as well. Then what would be the new number of terms when you remove one of them? It's going to be 68 or 69. Now, this new number of terms is what is going to lend us a lot of info, right, into solving this case. I know that the new average is 35, 7 by 17. That means the denominator had a 17 multiple. Average is total divided by number of terms. Total is always an integer. Denominator is number of terms. Number of terms has to be a 17 multiple for me to have a 17 here. Which number of terms over here is a 17 multiple? 68 over here is a 17 multiple. So this is what is correct, right? These set of values are correct over here. These I can ignore. I need to find the number erased. So the erased number is nothing but the old total minus new total. Old total was nothing but 35 into 69. That minus the new total over here, 68 into 35, 7 by 17. 35 into 69, I can write as it is, minus 35 into, there's nothing but mixed fraction is nothing but put a plus and put a bracket. 35 into 68 minus 68 into 7 by 17. 35 into 69 minus 35 into 68 is 35 into 1 minus this I can divide. I get a 4 into 7, 28 over here. 35 minus 28 comes to 7. Option 1, 7 is the answer here. So next up we look at items or people, I can also call it people, leaving or joining the group, right? Leaving or joining the group. Yeah, so let's look at this question 10, right? So the average height of 22 toddlers increases by 2 inches when 2 of them leave the group, right? So plain old simple, stick with average into number of terms equals total over here, right? Total over here. We have 22 people over here. The average is not known. But what's given over here as a connect is if the average height of the two toddlers is 1/3 the average height of the original 22. Original 22 average is 3a. 3a into 22 is going to be 66a. But the two people who are leaving, their the average of their height is 1/3 of 3a. 1/3 of 3a, which is a. So if I'm removing 2a, 2 times 1/3 of 3a, then that's going to give me 64a, and that's for 20 people over here. But the average is increased by 2 inches from 3a, not a, from 3a, right? From the original average, it has gone up by 2 inches. So 3a plus 2 into 20 is 64a. We need to find the average height of the remaining 20 toddlers. Remaining 20 is going to be 3a plus 2, right? So this is what we have to find, not 3a. So just need to solve for it. So 3a plus 2 into 20, that's going to be 60a plus 40, which is 64a. And we get a 4a equals 40 and a equals 10. If I substitute 10 over here, 3 into 10, 30 plus 2 comes to 32. So option 3 becomes the answer here. So question 11, the average weight of the students in a class increases by 600 grams when some new students join the class. If the average weight of the new students is 3 kg, more than the average weight of the original students, okay? The ratio of the number of original students to the number of new students is going to be what? Ratio of original students to the ratio of the number of new students. So what do we have here? The average weight of the students in the class is going up by 600 grams. And we have the average weight of the new students being 3 kg more than the average weight of the original students. We could use alligations over here, right? Let the average weight of the original students be A. The average weight of the new students over here is A plus 3. The average weight of the class is now becoming A plus 0.6, right? So these are the original set of students. These are the new number of students coming in. And if I use aggregations, difference over here is 2.4. Difference over here is 0.6. Simplify and I get 4:1. And that's the ratio of the number of original to the new set of students. Option 4 becomes the answer here. So very quickly, let's look at median concept application formula, right? So median, we know is going to be the n plus 1 by 2th term if n is odd, and if n is even, just it's going to be the n by 2th plus n plus 2 by 2th term, or some would say it is n by 2 plus 1th term, the next one divided by 2, a simple average over here, right? Why is that coming in? 1, 2, 3, 4, 5. If I have 1, 2, 3, 4, and 5 terms, arrange it in even or, arrange it in ascending or descending order, and then plug the 5 in odd number of terms. 5 plus 1 by 2, 6 by 2, third term over here. That's my median term over here. So if it's 1, 2, 3, 4, 5, 6, then 6 by 2th term, third term, 6 by 2 plus 1th term, this one. The two middle terms, find the simple average. That's the median, right? So where is this applied? I mean, people might ask this in the interview stage. Median is better when, in removing outliers. One huge value which is going to influence the mean and push it really high, right? It gets rid of those. Median is in fact used a lot with median salaries and others we look at, right, in terms of these schools. Mean is used in terms of where you're not going to have outliers, like average rating for when you're ordering on any of these big online retail companies, right? Amazon, Flipkart, and all of that, or your Swiggy, Zomato, your ratings you're going to see for restaurants. It's mean which is used, not median. Okay, so that's about it when it comes to median. Very quickly onto mode before we take an example involving both, right? So mode over here simply speaks about the term which is going to be occurring the most number of times. So if we have 1, 2, 3, 4, 5, and 5, then the mode over here is equal to 5 because it has come the most number of times, although it's the highest value. These are all supposed to be measures of central tendency. Mode over here tells me what has come the most number of times, right? 5. So what if 1 also came twice? Then the mode in this case is going to be 1 and 5. Mode is the only measure of central tendency across the three where we can have more than one value as the mode. If it's median, there's only one value. Mean, there's only one value. For mode alone, we can have more than one. What if the terms are 1, 2, 3, 4, 5? All 5 of them become the mode. Mode equals 1, 2, 3, 4, and 5. So at times in questions, they'll tell us that we have a single mode. We have only one mode. That means there's only one thing which is coming the most number of times. The rest are less than it, right? So one such question is over here, right? Question 12. Ramesh analyzed the monthly salary figures of 5 vice presidents of his company. All the salary figures are integers. The mean and median salary figures are 5 lakh, right? For who? 5 vice presidents. 1, 2, 3, 4, 5. The median is 5. Then what's the total going to be? Mean is also 5. So total is going to be 5 into 5, 25 lakhs. The only mode, only one mode is there, right? That's 8. So it has to be more than 5. 8 and 8 is going to appear twice. So the rest of them are going to come only once. Total over here, 16 plus 5 is 21. 21, if you remove from 25, we are left with 4 lakhs. 4 lakhs can't be 2 and 2 because only one mode is there, which is 8. So therefore, it has to be 1 and 3. So the sum of the minimum and the maximum over here, 1 plus 8 comes to 9. And that becomes the answer. If any of you are wondering why not 0, 4 and 0, technically it can be 8 and all of that, come on. Also logic we need to use. 5 vice presidents, somebody working at 0 lakhs per annum, unlikely, right? So we need to understand. Positive integer is not mentioned. Negative is not mentioned. 0 also can't be there. It has to be 1 and 3.